All right, now we have a little quick discussion of how you prepare documents. So you start with your input document from the web or from Word or what have you. And that has some text. Here's some sample text with a header and some text, and the text is either italic or not italic. Then you basically get rid of all the sort of bolds and things like that, or the HTML, and then you get a stream of words, and you've removed italic, for instance. Then you filter out the uninteresting words. This is not always done, or is done with different choices of uninteresting words. We'll mention that a little later on. Then we do the so-called stemming, which does things like converts computers to computer and switch to switch. So it takes every word and converts it to its sort of canonical or fundamental or simplest form. Then you finally make these final things you get are the actual tokens. And in this case here, it's Y2K, world, computer, switch, 2000, bug, report, and lab. And then the document is specified by which tokens it's have and how many times the tokens appear, and possibly the position in the document of the tokens. So how do we take this pipeline and look at it in more detail? So you have to get the document text. Well, that's not too difficult for Word or a text editor, but you have to suddenly have a reasonably good infrastructure enabling to be able to read Word, plain text, PDF, HTML, Excel, PowerPoint, different version of Word, RTF, XML, and of course OCR is often pretty flaky, and you would normally do the OCR manipulation as a separate step. So this is why I said it's engineering, this aspect of the web, because it's it's pretty hard, but the technology to do this has been developed. So here's a slide going through that tokenization, the first step in more detail. You remove the formatting information, such as HTML tags. You remove the punctuation, the comma here. You remove the capitalization, such that you have here, the bold face. When we hear Y2K becomes lowercase y2k, and then you get back your first set of tokens. There's also some more sophisticated things you do here, like you remove the full stops here. And so USA with full stops becomes USA without full stops. You remove the umlaut and naive and things like that. And so there are these various rules you have: no accents, no periods. There is some issue about uppercase, because sometimes uppercase is significant. But as noted here, most people actually query always in lowercase, or they're not very accurate in the case of their query. So the next step, which is done in various ways by different search engines, you remove the so-called stop words, which are the extremely common words which don't have much discrimination value in doing a mapping. So obviously A and the and R and so these by, these are all stop words in English. And of course there are some important phrases which only have stop words in them, like to be or not to be. But that's why I actually tend to, I think, keep the stop words, but process those stop words in a careful fashion in the actual search query. Then you view the match to the stop words as less important. But if everything is stop words, then you will actually consider them quite important. So here's an example of a case you would want the stop word if you really want the King of Finland, or to be or not to be as an example. You want to be able to keep that. So here's what Google does for King of Finland. It actually is matched properly to the King of Finland. Um, so it does not remove stop words from the raw data. So it may remove the stop words for many queries. Here we put this in quotes to insist that we want King of Finland in that order. So lemmatization is a fancy word for stemming, which basically means convert your tokens to standard form. And a good example here is that going from walking to walk is straightforward because that's the normal English form of related words. But better, best, and good is a very special case, and so simple algorithms will keep better as better, whereas a sophisticated algorithm might convert better into good. So that's a subtlety which, again, this is all engineering, and I assume the big search engines have been doing this for so long, they know exactly what to do now, and they have a wonderful set of lists to support this stemming or lemmatization. We've already mentioned this. We probably want to get rid of umlauts or convert them into some standard way, such as a umlaut becomes ae, and I'm not, and that's because there are some, like in German, the umlaut can sometimes be significant. The a with an umlaut is different from a without the umlaut, so these are different words. There are some synonyms you have to be interested in, like auto and can often mean car, but auto doesn't always mean car. It can be auto from automatic, as opposed to auto meaning automobile. So that requires special care. But again, it's reasonably straightforward. And these types of steps can be applied at different, they're going to get applied. Question is whether they're applied at this stage or later on when you get more flexibility. And as long as you have enough computer time, you probably tend to delay some of these steps. So as we said, we finally get this document representation, which is a bag of words or a bag of tokens. And I pointed out this is just a traditional vector space point of view. The axes of the space are the possible tokens, and the vectors have components and dimensions, which is the number of times each word appears. And or else you want to do it a little more cleverly with TF, IDF. But TF and IDF can be done later on because TF and IDF can be calculated from a data set which has this raw information. So we already mentioned that we want to form a so-called inverted index, and now we need to discuss that. Another thing we need to do is, which we actually mentioned last lesson, is the fact that many documents are importantly divided into components, which is the segmentation problem. It's very important, say, for Google Scholar or Microsoft Academic Search or Sites here, where you can take a document and divide it into segments like title, author, institution, abstract, body of text. The text is divided into figures and raw text, and the end of the document is typically citations and acknowledgements. So that's an important feature.